So moving on to the last question from this FP1 June 2016 paper. So it's question 9. And we have rectangular hyperbolas here, h. And we've got the Cartesian equation, x, y is equal to 25. And we have to show that the equation of a normal to h at this point P given here is this equation. So let's have a look at doing this. So we know that x, y is equal to 25, right? So I think there is a couple of ways you can do it, but the way I always take the approach to doing these questions is start off with y equals. So we're going to divide through by x to get that. So that's y equals 25 divided by x. That's 25 divided by x. And we need to work out a gradient at some point, so we're going to need to differentiate this function here. So dy by dx. What will that be? So hopefully nothing too intense. That's going to give me, so that'll be minus 25. So I'll write that down, minus 25 over x squared. So it'd be minus 25 x to the minus 2, but I'll write it as minus 25 over x squared. Like that. And what we want to know is what's the gradient of this function here at the point x. Or it's at the point p, but what's the x coordinate? So that's 5p. So what we're going to do is substitute 5p into here and square it. So at that point there, that's going to give me minus 25 divided by 5p all squared. So it's going to be 5p all squared. 5p squared. So that's going to give me minus 25 divided by 25p squared. So that's going to give me minus 1 over p squared once we simplify that. But we're working out the equation of the normal, not the tangent. So you've got to be careful here. Make sure you get the right gradient. So we're not using this gradient, but we're going to work out the negative reciprocal. So minus 1 over p squared. So what's the negative reciprocal going to be? Well, flip it. So that'll give me minus p squared and then times it by minus 1. So that'll give me p squared. So that's the gradient that we need. So that's my perp gradient. That's perp m. So p squared, that's my gradient that we're going to use. And now what we need to do is substitute this back in using these two coordinates as well. So that's going to be y minus 5 over p. Y minus 5 over p is going to be equal to p squared times x minus 5p. So let's have a look at simplifying this now and see what we get. So what I'm going to just do is expand this right hand side, so that's going to be y minus 5 over p. That's going to be equal to p squared x minus 5p cubed. And as you can see here, we're pretty much there now. We just need to take this p squared x across to this side, and we're going to add 5 over p to this side. So therefore, y minus p squared x is going to be equal to 5 over p. We're taking that across. 5 over p minus 5p cubed. And there we go, that's part A done. So that's the first 5 marks for this question. Part B, we're told that this normal meets the line with equation y equals minus x at the point A. And we have to show that the coordinates of A are these here. So the way to do this, again, there's a couple of ways you can do it. All I'm going to do though is using this equation that we've just worked out now, I'm going to replace this minus x here with a y, right? Because that's what we know, y is equal to minus x. So this is minus p squared x, or it's minus xp squared. So the minus x can become a y. So for part B, what we know then is that the equation will become y plus p squared y, and that's equal to this side again. Nothing changes on this side, so that's 5 over p minus 5p cubed. 5p cubed. So now we need to get this in terms of y. So how do we do that? Well, notice there's two y's on this side, so we can start factorising. So that's going to give me y multiplied by 1 plus p squared. That's going to be equal to, and then I'm going to factorise this side as well actually. So notice I'm going to pull out now the factor of 5 over p. I'm going to apply a factor of 5 over p. The reason why is it makes it a lot easier to deal with. So I'm going to apply 5 over p, and then in my bracket I'm going to have 1 minus p to the 4. So just make sure when you multiply this bracket back out that this 5 over p times minus p to the 4 gives you minus 5p cubed. And it clearly does, because I get 5p to the 4 divided by p, so that just cancels, giving me minus 5p cubed. So we're going to divide through by y. Divide through by the 1 plus p squared to get y on its own. So therefore, y is going to be equal to 5 over p times 1 minus p to the 4. And that's going to be equal, divided by 1 plus p squared, so the y is on its own. And now, think about where we can simplify here. This 1 minus p to the 4, it looks a bit funny, but just recognise it's the difference of two squares. So, I can write as 5 over p again. 5 over p. So it's going to be 1 plus p squared and 1 minus p squared. That's a p. 1 minus p squared. And then again we're dividing by 1 plus p squared. So notice now we can cancel these terms here. The 1 plus p squared cancels again with the 1 plus p squared there as well. So what do we get left with? We get left with 5 over p times 1 minus p squared. So therefore, I'm going to take it over here now, so just so you're clear with that. So finishing this part off now, we know that y is equal to 5 over p times, minus 5p, because that's all we've got left with there. Because if you multiply this out, that's 5 over p times 1, so 5 over p. 5 over p times minus p squared, so I'm going to get left with 5p. So that's that y coordinate that we've got there, that's that part. Now we need to get this x coordinate here. So what you need to do is replace the y here now with the minus x. So that would mean minus x is equal to 5 over p minus 5p, and we're going to times through by the minus to get x on its own. So therefore, x will be equal to minus 5 over p minus 5 over p times by 1 minus p squared. 1 minus p squared here. Because this is what we've got here. So I've just made it minus, so it's 1 minus p squared. And now I just need to multiply through. So that's going to give me minus 5 over p. And it's going to give me plus 5p. And that's part B done. So let's move on to part C. So for part C, we need to work out the exact coordinate here, or the exact value of the x coordinate at point M. So M is the midpoint of the line segment AP. So we need to work out the coordinates first of all, so the coordinates of M in terms of P. So what's that going to be? So that's going to be M is equal, oops, I'll change that to Y. So M is going to be equal. So all you need to do is add up the 2 points here. So you add up the point A and the point P. So you add up the x coordinates separately in terms of P, divide it by 2. Do the same with the y coordinates. So 5 over P plus this part here, divided by 2. So let's see what that will give us. So that's going to give us minus 5 over 2P. Minus 5 over 2P plus 5P. Plus 5P like that. So that's my x coordinate, and then my y coordinate is going to be 5 over p minus 5p divided by 2. So them are the coordinates now, but in terms of p. Now we're going to need to work out the exact value of this x coordinate here of the point M. So first we're going to need to obtain the value for p. So the way to do this is set y equals to 0. So when y is 0, what am I going to get? So I'm going to get 5 over p minus 5p over 2 is equal to 0. That's a 5p over 2, that's equal to 0. So I'm going to take it across, that's 5 over p is equal to 5p over 2. That's a 2. So 5p divided by 2. And then I'm just going to multiply across, so 5p squared. So 5p squared is going to be equal to 10. That's say 5, don't get confused, so that's 5p squared is equal to 10. So p squared is going to be equal to 2. So normally when we square root here, we'd have the plus and minus of the square root, but notice that m lies on the positive x-axis, so we ignore the negative value. So that's going to be p is equal to the square root of 2. And now we just need to plug this back in now, knowing this fact. So this is going to be, where did we have it? So my x coordinate here is going to be minus 5, so x is going to be minus 5 divided by 2p. So we're plugging it back in here, so it's going to be minus 5 divided by 2 lots of root 2, so 2 root 2, plus 5 lots of root 2, because it's 5 lots of p, 5 lots of root 2. So we need to simplify this. So how can we do that? Well, first off, we can rationalise here. So we've rationalised this part here. That's going to be 5 lots of 2 root 2, or minus 5 lots, that's going to be minus 10 root 2, minus 10 root 2. And then the bottom is going to be 2 root 2 times 2 root 2. So that's going to be 4 times 2 to give me 8. So that's minus 10 root 2 divided by 8 plus 5 root 2. That's 5 root 2 hasn't changed. Now we can simplify this here. So that's going to be minus 5 root 2 over 4 plus 5 root 2. And then how would I simplify this? So if I times this side by 4, or this 5 root 2 by 4, that's going to be 20 root 2 minus 5 root 2 divided by 4, so that's going to be over 4 as well. So that's going to give me 15 root 2 divided by 4. So I've obtained this value here by timesing it by 4, so they've both got a common denominator of 4, and then just performing the calculation. That's 20 root 2 divided by 4 minus 5 root 2 divided by 4 to give me 15 root 2 divided by 4. And that's it, that's the exact value of the x coordinate of point M. So I hope the paper's been helpful, guys. If you found it helpful, be sure to check out my channel. We've got a lot more papers down here. And be sure to subscribe, you know, I've got plenty of further maths content coming out and A-level maths content, so be sure to check it out, and best of luck.